You all know that technology comes in waves, and right now, visibility and telemetry is something that we just keep returning to on the packet pushes. We've spoken with Deepfield twice so far about the streaming telemetry from your devices and combining that with other data sources to give you real-time insights. We've talked extensively about flow data and streaming in the logs and combining all those data sources together and combining them with some really smart software. You don't have to read tea leaves. You start to get actionable information. Now, that basically means that Deepfield's going to give you some strong pointers into what you're looking at and what you need to do next. Instead of you looking at the tea leaves and going, I think Granny's offline at home, you can actually say, go and check Granny's internet connection. And that's what it's all about. Except Granny does this at web scale. And Deepfield does all of this in the cloud because, quite honestly, this is the only place that you can do it today. And you've got to feed in the data from the network wherever you are and get it into that analysis system. And today, we're going to continue on that discussion. We're going to dig further into use cases and basically just look at practical examples of how companies have used the Deepfield service to change their networks and the services that they're offering to customers. Today, we are welcoming Tony Kourlas, Director of Product Marketing for the Deepfield product at Nokia. Welcome to the show, Tony. Let's dive right in. Let's not cut any stuff in and just get right into the meat of the show, into the story of a gaming company and how they improved their network with Deepfield.
Hey, thanks, Greg. So gaming companies, they typically have games running in servers across one or more data centers across a country, across the world, and a geographically dispersed user base that is typically served by this nearest data center. Now, the bigger gaming companies also build some sort of backbone to interconnect their data centers, but the bulk of their connectivity is typically met by peering with regional providers, transit providers, and the like. Now, to interconnect all their site and reach all their users with reasonable latency, it's not uncommon to see a gaming company with well over 100, 120 peering points to manage. Now, as you would imagine, this is a Herculean task to get right. To make an informed decision on what to do about this, a decision that's best for my business, I need to bring in application, user, and internet context together. So for instance, what games are being affected? What is the data tonnage on a particular link for each game? What subscribers are affected? What is the data tonnage by game and by remote ASN that denotes where the subscribers are affected?
Now, this is a huge challenge for gaming companies because people are widely distributed. They can be on very different networks. The carrier networks, which are on the last mile, aren't like enterprises where everybody's connected on guaranteed high quality, high expensive MPLS internet tails. There could be, a second-rate broadband ISP provider who's basically oversubscribing at 400 to 1.
Yeah, and no matter what the circumstances, Greg, I can say as a former internet gamer that there is no such thing as what you said earlier, Tony, reasonable latency. And so, solving this problem is a big pain in the rear end.
Yeah, that's exactly right. There is no thing as reasonable latency. So it's very important that I'm able to look at traffic as it crosses across every link, get that application context, and make the best possible decision for my users, right? Pick the lowest latency peering links at any point in time and make sure that I'm utilizing these peering links as effectively as possible.
So in effect, what you're saying is that the gamers get pointed to a node which is closest to them because the internet is not actually a best path system. It's a path, usually the worst path, actually.
That's exactly right. That's one of the things that we could do. Another thing is that we can sense that a particular peer is congested, and even though it's the closest thing, something that's maybe a bit further away is the best decision right now. So it's having that information at your fingertips that lets you make this decision in real time. What is best for my user, what is best for a specific game.
I'm hearing two things that work together. One is the way you can take a whole bunch of different data sources, analyze them, and then come up with some sort of a recommended next step for the network. But then it's not that you're presenting that in a report to a human going, okay, human, figure this out. You're actually affecting a change to the network in real time to accommodate those circumstances. Am I understanding that right?
That's correct. So basically what you can do is you can bring in things like SDN automation. Automation is only good as the data that guides it. So if I see that I need to connect this particular gaming server to that peer, I can dynamically create a segment route from the server to that peering point and then spill that data out into that peering point in real time. So analytics not just sort of provides me with an instant view of what's going on in my network, but it's used to drive that automation that corrects the problem that would ordinarily take many hours or days into seconds or minutes.
So just so we're clear, with the Deepfield compilation of data from complex data sources and then coming to a decision, is the Deepfield engine then interfacing with an SDN controller to push out that change as you were describing, maybe set up a segment route to solve a specific problem? Or how are the data sources and results connected to the automation for the network?
So the data sources would come into the analytics engine like Deepfield. It would make that analysis across its multiple contexts, decide on what to do next, typically trigger a policy, and that policy then would use a variety of APIs, REST APIs or whatnot, to trigger an SDN controller to make those changes. So in the SDN controller, you'd note that, hey, if these conditions happen, then go ahead and set a segment route with these attributes and connect to these points that are being requested, right? So it's really the two working in concert through open APIs to provide the right decision at the right time.
Okay, so Tony, we talked a bit about the gaming use case for Deepfield, and that, to me, in my mind, is latency and optimizing the network performance between the gamers and across that gaming network. That brought to mind another media kind of a problem, video content, where I don't know that its latency is as critical, but certainly you've got data volume that's as critical, where buffering and so on, and you don't want to be dealing with that kind of a problem because you want it to be, well, as if it's a broadcast over-the-air experience. You want that to happen over the internet. I'm someone that's cut the cord, and I consume any media like that via streaming these days, and I'm always annoyed when I get buffering. So is there a way that analytics plays into smooth video content?
Yeah, absolutely. I mean, the network architectures are very similar between gaming companies and video companies in that they're both sending out content, except from a video content provider perspective, it's really about you measure customer experience from the standpoint of streaming quality, right? Am I high resolution, low resolution? And you really have to keep track of the amount of bandwidth. So all of that we discussed for gaming applies to video in that, you want to be able to look at all sorts of analytics, correlate that in real time, and be able to pick out your best peering partners at any point in time. And this is where we're seeing a lot of interest in taking analytics to sort of that next step by using, SDN to trigger corrective action when quality is about to suffer. So for instance, if you look at video content providers, many have multiple types of video services, and they can have massive swing-ups of traffic from day to day. So for instance, the latest Game of Thrones episode on their streaming service can dominate traffic one day, while the next day, the next video release may dominate traffic on the next. Now, this extra traffic essentially creates choke points in different parts of their own network, and it can also begin to dominating peering traffic in specific peering locations.
I guess this also feeds into content delivery network discussions too. So if you're looking at whether you should talk to a video provider, like for example, Netflix can put CDN node inside your network. You could start to use this information to know, is it time to approach Netflix and show them how much data you're spending getting them into your network, and would they please bring a CDN inside so you don't have to pay peering fees?
Yeah, so this is it. This is one of the advantages. Right now, I have this sort of dichotomy where, my traffic can shift day to day, and I need to be able to have many different kinds of partners and be able to switch from those partners at any point in time. So for instance, I can know when a particular port is saturated, but without that application context, I don't know exactly what is suffering, what application, what users are suffering. Once I get that, let's say by correlating bandwidth for a particular streaming service and saying, hey, this is pretty low. The average bit rate is pretty low for this particular service's subscribers. They must be getting low res. They're going to be upset. So then I can make that determination that this peering link is not a problem. And then I can look at other parts of my network and say, hey, I noticed that there's a peer available here that has good streaming quality. And so what I'll do is, as I said before, I'll use SDN to dynamically move those flows to this new peering point. And what's really cool here is that you're using new SDN constructs like per flow steering, right? So basically I can say only those flows corresponding to this affected service will move onto this segment route. And then I'll use ACLs or BGP or FlowSpec or whatever in the router to sort of redirect those flows and get down to that new peering point. So really cool applications of SDN and multidimensional analytics are being used in video customers.
Yeah, really demonstrating that you can't just use BGP and BGP policies to steer traffic around to your different peering partners. That's been done for a long time for various reasons, but when it gets down to the actual end user performance and what their application experience is, you have to have more intelligence behind the analytics that you're doing, which seems to have come up an awful lot in the last 2 years in packet pushers, where we're mining data from flows and then making forwarding decisions based on what those flows are and what the specific applications are. unique forwarding per application. It comes up over and over again. And yeah, and as you say, a great demonstration and use case of truly SDN here. But you got to be able to get the data. You got to be able to analyze that data and come up with those inferences to know what to do to make that unique forwarding decision.
That's exactly right. And it's all about the applications, right? Ultimately, the business runs on how satisfied those customers are. So without that application context and mapping that into your analytics, mapping that into how you can move information around, you really don't have much of a solution. So exactly as you said.
It's a very difficult challenge to be able to do that too. Normally, only way you've been able to do that is to use some sort of flow export and then put some software together, and you really can't do that at scale. As we move to 10 to 100 gig links, calculating this data is an enormous technology challenge, being able to put all that data together to get that visibility.
That's right. And you have situations where you're moving an entire AS over from this way to that way. And you're going to have to sit here and put, hundreds of thousands, if not millions of ACLs in a router to do that, right? So the hardware itself has to scale as well. The router silicon has to be able to make those changes.
Well, let's talk about another use case here, Tony. So we've gone through video content. We've talked about gaming a bit. How about ISPs, DSL, cable networks, these folks that are transporting lots and lots of volumes of data for their end customers? Did they get into, how do you want to put it, custom steering of traffic based on analytics of what's going through?
Yeah, the ISPs actually have a different, if not worse, problem. They're the ones that are transporting web-scale content, whether it's directly through web-scale sites or through partnerships with CDNs, transit networks, and the likes. They're transporting it directly to the end customer. Pretty much this has earned them the dubious privilege of being the first to be blamed for any performance issues that come up. I pretty much learned this from my daughter, and the sounds wafting from the basement each time there's a Netflix streaming problem, right? There's epithets associated with my local provider. Talking to my daughter, that generation pretty much expects, unlike us, they expect perfect screaming quality every time.
Wait, I would say I expect it too. I'm just trying to be a little more grown up about it when things break.
And so the big problem that their providers are having is that even though web scale content is growing from 65% today, I think, to what is it, about 80% forecasted by 2020 by Bell Labs, ISPs have very little knowledge and very little visibility into how this over-the-top content flows to their networks and through their networks.
Because they don't own that content. They just own this regional transport network.
That's exactly it. So they're not sending the content out, and so as packets pass through, what are they? I don't know. So I put in DPI, but that's not the answer because it's simply too expensive to put everywhere. And I don't know that you can put any DPI box outside your peering edge with the kinds of speeds and feeds we're looking at today. So without this end-to-end visibility, solving the performance problems becomes pretty much a costly guessing game of where to throw the bandwidth or the caches. Now, this has led pretty much to ballooning capital operational costs and lots of customer churn. And this is exactly the problem that Nokia Deepfield is solving for these ISPs. We correlate net flow traffic from peering routers with the cloud application visibility that we get from our cloud genome feed, and it's like turning on a light. Suddenly, you can see every application that comes into your network and exactly how it flows through every node through your network. So instead of being able to tell you through DPI, mind you, if the packet was encrypted, you could say nothing, but assuming packets are not encrypted, I can tell you that, hey, as this packet that reached port 60 on my peering edge, that comes from Netflix streaming server that was in this level 3 cache, and it went through that transit network to hit this port in my peering router. So, at this point now, you can very easily figure out what the problem is. A CMTS went down, I have not enough capacity here, my cache is not working properly. As you track the flow, you can easily figure out those performance problems.
Because you're looking at a flow that's going through a route unexpectedly. Why am I seeing this heavy load of traffic here that I do not normally see, even though everything else should be is normal? And now you can highlight it end to end, right? Okay, because if you're just staring at counters and not analyzing the flow, of course, you don't know. Now, Cloud Genome Project tells me, it's this, and here end to end is how it's flowing through your network. And so now right, got it, I'm with you.
There's a very interesting example of how convoluted these things can get. There's this one particular ISP that received lots of customer complaints about poor streaming quality during peak hours in a specific region. So, they threw a lot of bandwidth at the problem with that region, but the problem refused to go away. So they started employing multidimensional analytics And once they started tracking all the OTT applications and how they flow through the network, they pretty much figured out in a matter of minutes. It seems that Netflix traffic was being clipped during peak hours of a specific pop. And because the local cache was misconfigured and not handling all the traffic it should have, the backup cache that was employed was located over 1,500 miles away. So clearly, you're going to get pretty poor streaming quality. So all it took really, after months of agony was a quick cache reconfiguration, a small addition of bandwidth to the affected POP to resolve the problem. And, it kind of pretty much points out that, without that kind of visibility, to resolve complex problems like this would require, either extreme luck or divine inspiration or probably both.
Divine inspiration.
I've always bet on divine inspiration. Usually that was just me trying to pretend I actually knew stuff.
Tony, you mentioned a term that I wanted to clarify. You said multidimensional analytics. And does that go back to what you were talking to at the top of the show where you mentioned just pulling in all sorts of different flow data and port data and so on and correlating all that together? Or does it mean something more specific?
Yeah, sorry about that. I should have clarified. Yeah, that's exactly it. So basically, I take topology data, I take BGP data external, I take the cloud genome feed, which is actually something that's unique to Deepfield. What we do is essentially start out thousands and thousands of VM that troll through the internet and build a supply chain of the internet, which is how, as I said earlier, we can figure out, this is Netflix coming from level 3 through this transit network. We use the cloud genome feed to correlate with every NetFlow feed from your routers, right? So we can put whatever information is the network, and also we can add your information to provide the kind of context that you want, and we crunch that up every few minutes.
So you talked about the ISP that fixed the caching problem, essentially, because they could give us another use case here for ISPs, Tony.
Yeah, there's actually another interesting story around a billing dispute that an ISP was having, and they knew it was wrong, that they were paying just too much to this other ISP, but they couldn't figure out what was wrong because they didn't really have enough visibility into what kind of traffic was flowing through their peering routers and exactly where it was coming from. So, they saw lots of tonnage, but not content flows, which made it very difficult to go back to the ISP and says, hey, you know what? I got a problem. So what they did
the old story, prove my invoice is valid. And then a peering invoice is actually incredibly difficult to do.
Yeah, and it's huge. You wouldn't believe how often this kind of thing happens. So what they did in the end is they tracked each application flow that passed through their network using, Deepfield Analytics. They checked its origin against their own traffic logs, and they quickly discovered that the culprit was really the CDN provider. What they were doing is they were basically taking traffic, their own traffic, and pushing it to this other ISP that was billing them. And then essentially that other ISP would bill back that first customer, right? So essentially it was just kind of sneaking traffic in and through this particular ISP's network and then fronting the bill, right? So they figured this out in seconds when they turned on the analytics. And as you can imagine, they went to the CDN provider and remedied the issue. There's a similar kind of example with this other ISP that was basically being charged for one service, a CDN service, when in fact they had purchased the transit service. And they realized that only when they turned on analytics, plugged in the cloud genome, and discovered, hey, you know what, that's the wrong service you're billing me for. I can tell because it says here that, I should have this IP address, not the other. Yeah, I mean, you'd be surprised how often it happens. And it's a really, for the bottom line, it's huge, right? Because, this...
I think it's been this, we've had 25 years of the WAN, whether you're a carrier or an enterprise or any managed service provider, you really have very limited visibility into what's going on the WAN. And we've always just counted bits and then relied on the network engineer to know what's going on. And there have been various tools come in over the years where devices have started to express application awareness by packet headers, but encryption takes a lot of this away. And, things are changing against that as well. Not only is there more bandwidth, which makes it harder to do that analysis. And I think every time people get more visibility and get more telemetry into what's going on top of the network gets more valuable to everybody. And that's an example of that to me.
Yeah, that's exactly it. It's interesting that you mentioned encryption because there's a lot of use cases we're finding where there are DPI limitations, like its inability to sort of see past encryption. They're creating big problems. There's this specific use case where you had a customer that, again, was having quality issues from a group of customers, right? So basically, customers call in and complain. They have no clue what the problem is, right? And they don't know where the problem is because the only thing DPI tells them is that, hey, this traffic from that OTT app has dropped because they haven't deployed it everywhere because it's way too expensive to deploy everywhere, right? So unless the problem is happening exactly where I put the DPI device, I don't know where the problem is. And then if the flow is encrypted, well, then I can't see it anyway. So I don't even know I have a problem. So by employing multidimensional analytics and using Cloud Genome, and what this particular provider did is they turned it on and they discovered in seconds that, oh, look, this particular CMTS has lost Netflix, right? All the Netflix flows have ceased, and that is affecting, 800 subscribers in this particular ASN, right? So boom, they don't have to wait for them to correlate all the other data coming in and alarms and whatnot. They know exactly what's causing those calls, and they can go in and fix the problem, right?
So there's another use case coming up where in the European Union, there's been a lot of legislation come up around GDPR, where citizens have a right to privacy and ISPs need to be able to do that. Is there something that Deepfield can do in that for me?
Absolutely. So this is actually a huge topic because a lot of these European providers, what they want to do is they want to get all this information about their subscribers, their demographics, what they're doing, and then sort of tie that to how they consume the ISP service, right? So they do that really because they want to, provide a better service for them, provide them what they want. The problem now is, though, that it's taking all this data and correlating it, right, and keeping it, storing it is a problem, right? So you can't do that anymore. That violates privacy laws. So what's happening is they're using Deepfield to essentially, the service provider puts in their demographics, right, the rate plans, geographical location, type of customers, a whole bunch of different demographics, and they correlate that with the applications that a particular subscriber is using, how much of that they're using or it's flowing to, and a whole bunch of other things. And then they're also pumping in radius because, in essence, IP addresses can change many times a day. I mean, it's almost impossible to try to correlate this stuff afterwards because how do you keep track of all those IP addresses? But if you do it in real time, you correlate all in real time, you crunch it up, and then you anonymize it. So you can say, hey, these kinds, you save it by rate plan, right? The customers of these rate plans had this kind of behavior, right? Customers in this geography had that kind of behavior. So now you've anonymized that information. You're not violating privacy laws, and you have a good amount of information that you can use to either optimize your network for specific kinds of customers or, know exactly when to offer them something, right? This guy probably wants more bandwidth. I can tell that from his demographic. So a very cool new usage of this technology.
Mm-hmm. There's a whole bunch of really interesting outcomes to that too, because GDPR is actually quite convoluted and involved. It's very difficult to understand it at a lot of levels. So let's move on to the topic of distributed denial of service. Now, most of us are familiar with DDoS because it happens quite a bit these days, and it keeps hitting the press and the security news about that sort of thing. But a lot of people don't understand that you can use visibility tooling to get help with that as well. So let's start off with some stories around what you've seen with DDoS.
Yeah, it's been a very interesting 12 months, and basically whether you're a web scale or an ISP or whatnot, DDoS attacks impacts you, right? And it interrupts with the service that you're offering to your customers. Your customers are pissed, and, you have a big problem. So there's a lot of suffering here, and that suffering has really increased over the last 12 months. We've seen attacks of unprecedented frequency, scale, bandwidth. We've definitely crossed the terabit era and are seeing, essentially millions of attacks per year. So take for instance the DIN attack, right? You had hundreds, if not thousands, of cloud servers that were hijacked, each with 10 gig links, and I think it's like 100,000 IoT devices that were also hijacked because they had poor, security, leaky kernels, whatnot. They were hijacked, and they had this sort of multi-pronged attack that brought down much of the internet infrastructure. So the problem with all this is that the current architecture for DDoS protection, no longer scales, right? You have a detection of appliances that essentially look for anomalies, like large spikes of bandwidth headed to a particular site. Once they kind of trigger, once the threshold is triggered, what they do is they use BGP to redirect traffic headed to that site down to a scrubbing center where they have a whole bunch of appliances that essentially do the mitigation. Now, the problem with that is that one, it's a very expensive way of doing it, right? If I have a terabit attack and I have to take a terabit's worth of bandwidth and send that across my network to the scrubbing center, and I got to buy a whole stack of appliances that can keep up to those kinds of speeds, it gets to be a very expensive solution. Secondly, bandwidth anomaly detection is not sufficient on its own to distinguish between, say, a real attack and a sudden burst of traffic from Amazon. And this leads to false positives and false negatives, which, kind of detract, right? You're not really solving a problem, you're creating another problem. And finally, the whole process is rather slow, as all attacks require kind of a special intervention in the scrubbing center to identify them and to mitigate them. And while this is going on, a lot of carnage is happening, to your customers, to the internet as a whole.
So how do we fix this? How does Deepfield come into the situation and say, how do I see a DDoS attack, and then how do I decide what I'm going to do to mitigate it or to deflect the attack?
Yeah, this is where the analytics piece comes in. So we're looking, most of the customers we engage are looking for multidimensional analytics to replace these DPI boxes because they can identify and detect attacks faster and more precisely. So, for instance, if I see a bandwidth surge, and then I can quickly correlate that with application data. I can correlate that with packet ratios. How many send packets, normal packets? I can correlate with the cloud genome that tells me, hey, does this look like something that came from Amazon? And once I do that, I can quickly say, yeah, you know what? This is an Amazon thing. Don't touch it because they'll be mad, or let it go, right? And I can do this relatively instantly. The other piece I can do is with cloud genome is I can instantly recognize friend from foe. So let's say I've identified, there's like in DIN, there's a whole bunch of IoT, a whole class of IoT devices from these services that have been hijacked, and also a whole bunch of, cloud servers from these rickety sites. That may be well and good, but I still have millions of IP addresses hitting me. How do I know, which are good, which are bad? So if I have a map of the internet, I can go put 100,000, several 100,000 ACLs that map those IoT devices and those cloud servers and stop that traffic before it enters my network.
Well, I mean, that's what the function of mitigation services is. Once you detect a DDoS service, you send it off to a mitigation service. And these mitigation services are able to read those packets, decide which ones are part of a denial of service attack, and then filter them out and allow the rest of the good traffic to pass through and then to the client's end hosts.
But Tony, those services like that, you're recognizing the good from the bad and picking that out among millions of IP addresses has been notoriously difficult to pull off. You got the scrubbing services that can do it and so on, but it's been a tough one where a lot of DDoS mitigation ends up erring on the side of, well, we'll try to let something through, but you end up just protecting the host, and so it's really been the holy grail to let the good stuff through while the bad stuff gets filtered. I mean, you need to convince me that Deepfield's really got the corner on this and has figured this thing out.
Cool. Yeah, I think we do. So if we look, so let's take a typical example, right, that I was trying to say earlier. If you have visibility into the IoT devices, if you know what their IP addresses are and they're offending from this area, you can just put those filters in at the edge of networks and get that stuff out. As well, if you look at most volumetric attacks, a little filtering. So for instance, I can look into the payload using filtering capabilities at my router edge, and I can tell, this payload looks specific of a DNS attack. I can take that information, right? And then I can correlate that with Cloud Genome to see where this kind of traffic is coming from. And then I suddenly know who my attacker is. And I can put in more filters to bring him out. And it could be as simple as a five tuple, right? Like an ACL or something. Or I can use the filters themselves in that silicon to filter out all requests that have, this kind of attack vector.
But the key goes back to really understanding the endpoint IP address and having properly classified it to, as you said, that this IP address fits into this specific classification of device and therefore can be treated in a particular way, as opposed to what a lot of the solutions seem to do, which is more behavioral analysis and trying to, using heuristics and maybe looking for statistical anomalies to try to determine what's really going on with a flow. You've got more insight and inference you can make about a flow because of the genome database. You've classified all of those endpoints to know what they really are.
That's right. So we have that genome database, and then we also have the ability to filter through routers, right? You have routers now that are capable of doing millions of filters in real time. So you can filter out.
Wow.
And then
routers. Not all routers, right?
Well, yeah, like the FP4 from Nokia, but fair enough.
Yeah. We did talk about, I've covered the FP4 silicon. It can do filtering at line rate. So now the trick becomes, how do I load rules into the silicon that it can filter?
That's right. So basically, it's through this analysis of taking all the, the cloud genome and all the different dimensions, and then essentially figuring out, where the attack is coming from, and then going back and loading those filters. And typically that's done through, REST APIs or other mechanisms, right? That I would bring them in.
Yep. And I think that's key, is that we're now seeing silicon which can actually do, in the past, DDoS, distributed DDoS at 100 gigabits or 200 gigabits per second was almost, you couldn't solve that in a physical device. And you've got to have telemetry to be able to see the denial of service and to identify where it is, and then extract the data set out of that source destinations and so forth. And then you've got to have a device that can do the mitigation. So something that can actually do packet filtering at hundreds of gigabits per second. And there's actually a partnership there that Nokia's got. So if you're a telco or a carrier or an ISP and you want those type of capabilities, you don't need to buy custom appliances like you used to 5 years ago, 10 years ago. You can do it in your petabyte class switch.
Well, it's even more than that, Tony, right? Because it's not just like a device you drop in at a key place. You've got to be able to filter at all the places, multiple perimeters.
Absolutely. And this is something that is relatively new. We're having a lot of customers seeing that attacks are coming both from within their network as well as without. So, for instance, you have attackers taking malware and essentially injecting it into, a PC or an IoT device, and essentially taking those over. The malware propagates and at some point reaches critical mass, and it starts attacking the server's own infrastructure, right? And bringing those servers down, clogging networks. So what we're doing is working with a lot of the ISPs to essentially put a fire blanket on these attacks the minute they start to smolder. So basically, we turn the analytics the other way across multiple perimeters, the server farm edge, the subscriber edge, look for activity of malware propagation, look for activity of a DDoS attack starting. And then we essentially go through SDN or through Radius or whatever and start rate limiting things, right? So basically, look, this coming from these subscribers, you go off and you rate limit that at the BMG or, at that router in front of those servers, right? So essentially that now you have time to go back and tell those users, you know what, you need to change this, use the software, reboot your IT device, whatever it is you need to do to sort of fix that problem. So we're going from this Maginot Line philosophy where, in Second World War, it was like, well, no one can get through our impenetrable wall across the German border. Well, they just came around it, right? And in the same way here, you can't just pretend, that attacks come in through the peering edge, right? Once they're in, there's nothing in the networks to effectively stop them, and you need to put that stuff in there to make sure that these internal attacks aren't bringing down your own network. We're not getting rid of appliances. Basically, 90% of attack traffic, which corresponds to volumetric attacks, can be stopped by leveraging your routing edge, right? Your routing silicon and complex, and analytics basically through Deepfield. And about 10% is still kind of application level attacks that require stateful analysis. So what we're seeing is, the appliances shifting their focus to solve those problems, right? And then this makes the whole thing scalable, right? Because as the volume of attacks rise, the gigabit levels rise, they can't keep up. But, they can focus on this particular problem. So what we're doing is we're sort of, dropping down scrubbing center traffic by 90% and focusing these appliances on application level stateful analysis attacks.
Okay, the point being there, Tony, then is that, right, you're clearing out a bulk of traffic, a volume of traffic. So there's going to be still some negative traffic that's around, but as you're pointing out that it's maybe at the application level. And that's where appliances can still shine and still have a role on the network. They can basically continue to scan what's left. Now that using Deepfield, the filters have been put in place to clean up everything that's inbound. Now you've got a pretty good stream, but still some application level stuff. The remaining appliances that you've already got in place, clean up that, do the inspection, and then presumably clean up the rest. Is that what I'm understanding?
Yeah, that's exactly right. They excel at stateful analysis. And the routers in Deepfield, excel at stateless analysis, right? So you basically put each device to perform in the area that it does best, and that way you get a far more scalable, far more cost-effective solution.
Well, I think we've probably taken this topic as far as we can go in the limited time we have available today. So what we've been doing is talking to Deepfield Networks. We've covered a little bit of work about how Deepfield can help you in the gaming sector, in the video content providers, with ISPs, and then particularly ISPs who are running DDoS mitigation services. I mean, you could run the same software as an enterprise as well, but today we chose to focus on those avenues of the market. Tony, why don't you tell people where they can find out more about Nokia Deepfield?
Nokia.com and at Nokia Networks on Twitter.
Thanks very much to Tony for joining us today. Tony can be found on LinkedIn if you want to connect up with him and fire questions directly to him. And of course, you can always leave comments on this blog post. Every podcast goes out with a blog post. There'll be some information and some links there where you can find out more information. Our thanks to Nokia Deepfield for sponsoring the Packet Pushers today. For more nerdy details about how their solution works, be sure to listen to episodes 283 and 352, where we deep dive very much on the technology side. Remember, today was about use cases and how you could apply this to your network. If you want to get more inside the technology, episodes 283 and 352. And of course, over at Nokia.com, you'll find a whole bunch of technology. Just search on the word Deepfield. Lots of actually very good white papers because I use them to study up for this show. You can find this podcast and many more fine free technical podcasts along with our blog and our news archives at packetpushers.net. You can follow us on the Twitter as @packetpushers, find us on the LinkedIn, like us on Facebook, and rate us on Apple Podcasts. That would be just great if you could do those things for us. And last but not least, remember that too much networking would never be enough.